All right, we need to go over some of the problems from the homework.
Where's the black?
Some of the other class requested it. So you could do them all, Tom?
No.
Okay, which ones do we need to go over?
Can we ask like homework 1 question?
From homework 1?
Yes.
Then how come you didn't ask it on that day?
I did it yesterday.
That's not video. I'm going to show this video to the administration.
No, but I caught up everything.
Okay, you know what? Maybe we should collect homework every day then, if we cannot be responsible. Okay, which ones do we need to go over then?
I just want to know if for 28 and 30, do you just make them equal? Because I just
For which one? 28 and 30?
No, like, okay, so for 30, I just added them together, but I don't know if that's like 30.
Yeah, you combine the equations, because that will give you the intersection, right? Right, when you combine equations together, you're finding the intersection of the two curves.
That's how you just combine it, that's it?
Yep,
Oh, okay.
that's exactly how you do it. Okay, so what about last night's homework? Psalm?
Yeah.
Which ones do we need to go over?
Can you go over? Yes. To be honest, I did
This is the kind of stuff that's going to be in my brain when I'm typing your letter.
No, I was like,
Song was a student in my class. Sincerely, Mr. Park. That's it. That's what you want your letter to be.
Can you go over number 4?
What?
Well, okay, the other class wanted 4C and E.
Yeah, that's exactly what I was asking.
Okay, in order to do 4C, okay, why don't we review something from BC Calculus? Okay, give me a formula. The area of a cube is side cubed, right? So when you take the derivative, you get dA dx is equal to 3x squared. So dA is equal to 3x squared dx. So what does this mean? Didn't you guys go over differentials in BC Calculus? Okay, so what is dA? The approximate change in area is equal to 3x squared times the change in x. So for example, when you have a cube, okay, let's say x is, give me a number for x, 2. No, I don't like 2, 4. And let's say dx, the change in x is, give me a small number.
2.
Oh, a small number.
0.5.
Like 1/2 then, okay, 1/2. What would be the approximate change in area if the side increases by 1/2? Well, the approximate change in area would be 3 times x squared, which is 16, times dx, which is 1/2, and that comes out to 24. So that would be the approximate change in, what am I saying area? This is a volume. Why isn't anybody telling me? This is a volume, you dumbo. The approximate change in volume will be 24 cubic units. That's an approximate change in volume using the tangent line. Do I need to draw pictures? Are you sure? Here, and let's compare that with the actual change in volume. What is the volume when x is 4? 64. What is the volume if I increase that by at 4.5? Song, redeem yourself.
Okay, 4.5.
And don't just say 4.5 cubed.
That is obviously,
Change it to a fraction then. 9 halves. 9 halves cubed. I'll do the denominator. 8. 9 cubed, come on, you're supposed to know your cube numbers up to 10.
729.
729. Okay, change that to a mixed number. That's easy, look. 8 goes into 72, so 91 and 1/8. Correct?
Yes.
Okay, so what was the increase in volume then? It went from 64 to 91 and 1/8. What is that? 27 and 1/8 compared to that. See, but this is using the tangent line. And 1/2 is kind of a big number for dx. It works better when it's smaller, like 0.1 or something like that. Anyway, you remember this?
Yes.
Okay, so that's how you do problem 4. What did I say we're doing?
4C.
Okay, 4C. So what do we have? We have the law of cosines formula. A squared is equal to b squared plus c squared minus 2bc cosine angle A. Now, which ones are the constants? B, C, and A are constant at those numbers given. Using find the rate of change of A with respect to B. So B is your variable here. So what are we trying to find again? Find the rate of change of A with respect to B. So, do you want to solve for A? Or do you just want to do like implicit differentiation? Well, can we do it?
2A, yeah.
Yeah, but see, because this problem is not really multivariable calculus because only B is the only independent variable, right? All the other things are constant. So, 2A, how do we want to write this? dA dB, right, is equal to 2B, that's a constant, minus, this is all constant stuff, so minus 2C cosine A, correct? So, A is equal to, why don't we just divide everything by 2? So A is equal to, A dA is equal to, why don't we just do dA? Let's solve for dA. How do you solve for dA? Come on. B minus C cosine A dB over A. So the approximate change in A is equal to this times dB. And then just plug in those numbers. Do you want me to plug it in for you, Tom? Okay, you plug it in then. Go. What do I plug in for B?
B decreased, but it's a B minus 1. What?
Look, it's all given, look. Are you even looking at the B is 10, C is 15, and A is... Are you even looking at the right problem? Are you in the right class?
9 minus 15.
Okay, everybody better check in, because I don't remember a 9. It says B is 10.
Oh, 10.
I'm asking you so that I don't have to walk over there and look at it. Okay, go.
10 minus 15 cosine pi over 3.
Yeah, but come on, what is cosine of pi over 3?
What at?
And what is dB, the change in B?
dB is
-1.
-5.
Using the result from B, calculate the approximate change in A if B is decreased by 1.
Minus 1.
Okay, minus 1 all over A. Oh, this should be fun. This is hilarious, yeah. Are you...
I do it right now.
Wait, who's your teacher last year? Maybe Miss Klein would be better suited to write your letter of recommendation. I'll give you a hint. You did it in 4A. If you did problem 4A.
It's 5 root 7.
Whoa!
Oh, geez.
There you go. That would be the approximate change in A. These are called differentials. Okay, and then 4E. The other class requested this, 4E. So what does that? Find the partial of C with respect to A. The partial of C with respect to A. Now, how do we want to do this? Just do implicit differentiation?
Yeah.
Okay, so that means A is your independent variable. Okay, so who's gonna do this? Whose turn is it? Hong, go.
0 equals 2.
What? Oh yeah, 0. No. A is your independent variable.
Isn't it?
Oh, like it's A, like capital A.
What?
That's
E is capital A.
It is?
Yeah.
Oh, okay. Oh, okay, there you go. Okay, go.
0 equals 2C del C over del A and dC over dA.
Wait. Is that what you call it, del?
I searched out what that was called, and it's called like Daba del.
Dabba del?
No. It can be called Daba, or it can be called del, it can be called like D.
Where did you learn that?
I searched it out like yesterday.
It's not delta.
No, it's not delta.
Del.
I think del.
Yeah.
I think I remembered that from college when I was paying attention. Okay, continue. 0 equals
2C del C over del A, and cap A, plus 2BC sine capital A, minus 2B cosine capital A, del C over del A.
Okay, I missed that. Did you say C sine A
Minus 2B,
minus?
yeah.
Oh wait, isn't this a minus right here?
No, it's plus because if you take the, how do you call it?
Why don't we just leave it minus and then you just take the derivative of this stuff here? But B is a constant, right? So just do it like that. You know what I'm talking about?
Wait, I got plus.
Well, just, okay, don't even look at your work, just look over here. Compute the derivative of this.
Wait, that's what I did. 2B and then cosine, like the derivative of cosine is negative, like there's a negative, so I just moved it to plus.
Oh, okay, so here. So minus C sine A
Yeah.
plus,
Plus minus 2B cosine capital A delta C over delta.
what? No, we
Oh, you're having it
we
bracketed?
factored out the negative 2B because it's a
Then
constant.
cosine capital A del C over del A. I cannot really see the board, that's why.
Well, how can you not see the board from there?
I'm covering it.
Okay, and then all you have to do now is solve for del C over del A. Do you want me to do that for you?
Wait, is it del C or del A on all of the things?
It's just those two, not the middle.
Okay, so look, if you multiply this out, 2C del C over del A minus, no, that's a plus 2BC sine A minus 2B cosine A del C over del A. So there's only two terms with it, so you want to move it on the left or keep it on the right?
Move it to the left.
We're going to move it on the left just for that. So 2B cosine A del C over del A minus 2C del C over del A equals 2BC sine A. And then if you factor it out and divide, then del C over del A is equal to 2BC sine A all over 2B cosine A minus 2C. Is that the answer at the bottom, Song?
Yes.
Faster.
Wait, look at it first.
Faster.
Oh yeah, we can cancel out the 2's. Okay, now is that the answer at the bottom?
Yes.
Then you said yes the first time though. Oh my goodness. Okay, so when you take partial derivatives, you just gotta keep straight which ones are the variables and which ones are the constants, and it's not difficult at all. Okay, so now that we know how to do first order partials, now we're gonna do second order partials.
Oh.
Oh, it's just gonna turn the thing.
Oh, what?
Wait, what does that mean? Fire drill?
This is.
Okay, wait, let me check what's going on here.
Why are the lights going? Because it's natural fire.
Is it natural fire? I don't
Did
think
you-
it was one.
Okay, we're going to the baseball field.
Yeah, we saw that drawing.
Did you guys walk up these stairs here?
Yeah.
I thought you were supposed to go the other way.
Everyone was just
No,
like,
Bernie and I took the other way.
What's, it's against the fireplace.
I'm winded. Oh no, we gotta restart everything.
Why do you bring it that? What's the violent kind? Yeah.
Alright, you guys watching on the video, you're just gonna have to fast forward. Well, I walked up the stairs so slowly, yeah. So winded.
I think it's a mess.
just take it off.
Yeah, I think it's a mess.
Drink water.
Can you see me? No. That's so
They can only see Josh's like head part. Oh my god.
Song,
Sorry.
Song, turn on the, is it on?
It's on.
How come nothing's up there though? Try turning it off and on. Oh, you just leave it? Okay, let's go to the main power thing here. There you go. All right, this is the last lesson of this chapter. That's why this chapter is the easiest test of the course. No notes for this one, because come on, you don't really need notes, right? Okay, so if you can do a first partial, that means you can do a second partial. Where's my chalk? Did I put it near my desk? Okay, now there's two different notations now, and you gotta get used to them. So, I put notes for you on the top. So if you take the partial with respect to x, and then you do it again with respect to x, see again, you gotta do what's in the parentheses first, then we call that the second partial with respect to x. So it's written like this. I guess we should write it properly. Or, in the other notation, it's like this. See, that's not confusing because, right, you're doing it with respect to x twice. Same thing with respect to y. But if you do it first with respect to x and then with respect to y, then you look at the notation. See, when you do it with respect to y first, and then with respect to x, look at the notation. When you use the del notation, you gotta go. You do the right one first, and then the left one. But if this is the notation, you have to do the y first and then the x. Is that confusing? See, I can't see that far. Doggone it. Second partial with respect to y, then with respect to x. So this notation, you have to do this one first and then that one. But if you use this notation, you do that one first and that one second. That's just the way it is. I didn't make these things up. But the good thing is, the second partials are always going to be equal regardless, the mixed partial rather, regardless of what you do which variable you do first. So let's do a problem then. So let's say you have a function of x and y. Okay, give me some interesting functions here. So, learner, give me one. Give me an interesting one.
2xy sine plus y.
And that's it? Let's put a square on one of these. How about that one? And let's put a cube on that one. Yeah, okay, something like that. So, let's say we use this notation. So what would be f of xy? So that means you're going to take the partial of x first with respect to x, then with respect to y. So what would be the partial of this with respect to x? Oh, so that means we have to do this first. Park.
2x times cosine of x cubed plus y squared times 3x squared plus sine x cubed plus y squared times 2.
Oh, what? Okay, everybody understand that? Okay, now we have to do it now next with respect to y. So what's the partial of this with respect to y? Pong. Oh, you can actually simplify that together, right? To 6x cubed. That makes it simpler.
6x cubed, negative sine x cubed plus y squared times 2y. Plus, where is it? Oh, 2 times cosine x cubed plus y squared times 2.
Oh, what? No, we're doing it with respect to y times 2y. There you go. Okay, but now let's do it the other way. Let's do the partial with respect to y first. So, learner.
2x cosine x cubed plus y squared times 2y.
Okay, and then the partial, after we do that, then we do it with respect to x. Kanashiro.
2 times cosine.
Well, why don't we simplify the 2 times 2 is a 4 then?
Okay, 4y.
And why don't we put the y in the front there then? Okay, 4y.
Cosine x cubed plus y squared. Plus 4xy times minus sine x cubed plus y squared times 3x squared.
Is that the same thing that we have up here?
No.
What do you mean no? It's supposed to come out.
Yeah.
Yeah.
Oh, yeah.
Same thing.
It is, right? It is. Who said no?
I didn't see that too wide.
So that's the good thing, the mixed partial. That means with respect to x and y, it doesn't matter which one you do first, it's going to come out to the same thing. So that's something good here. So tonight's homework is really easy. And then what happens when you have like multiple? See, partial derivatives of higher order. See, like, so this is the third partial. Here, I better write it on the board. What if you have to take a third partial and then you have, okay, I'm trying to look, del x del y squared. So that means you differentiate twice with respect to y and then one with respect to x, because when you do this notation, you have to go this way then, yeah? So you go with respect to y, then with respect to x. Okay, so let's just do one to just make sure we got it. This is just all mechanical. we're gonna apply it next chapter. Okay, so give me what's an interesting one here? Give me an interesting one, Song.
2x
Yeah.
ln
Ooh,
x plus y.
okay, we'll go with that. Okay, why don't we compute, no, let's do something different. Compute the third partial. How about with respect to y, with respect to x, and then with respect to y? No, I don't like that, because on a test, the people that went this way could get it correct then, yeah?
Oh.
You know what I mean? So why don't we do this then? Partial x squared. So you gotta, remember, this notation, you gotta go this way. You take the with respect to y first, then with respect to x, then with respect to x. Okay, so what's the first one? Take the derivative of this with respect to y. Park.
2x times 1 over x plus y.
Oh yeah, that's it, yeah. Okay, let's simplify that to this. Now you have to take the derivative with respect to x.
Oh, wait.
What do you mean, wait?
So-
What? Just for that song. Take the derivative of this with respect to x.
Oh my.
Easy. It's called the quotient rule.
X plus y times 2 minus 2x times 1 plus y.
What? What? Y is a constant.
Oh, 1
1.
over x plus y.
Okay. Shall we simplify that? Yeah, we simplify it. And you get 2y all over x plus y squared. Right? Because the 2 x's cancel out. Do I have to show that step? And then now you take it with respect to x again. So what's the derivative of this with respect to x, learner?
Negative 4y over x plus y cubed.
Oh, that's good. That is correct. You guys know how you got that?
Yeah. No.
This is the same thing as 2y times x plus y to the negative 2. This is a constant, so you don't have to use product or quotient rule. When something is a constant, you toss it on the side like an unwanted pet, right? Meow. So negative 4y times x plus y to the negative 3 times the derivative of that, which is simply 1. And that's how you get that thing right there. So again, you got to keep straight which ones are variables and which ones are constants, and then you'll be fine. So what do you think on the test? A fifth order? A fifth partial? Why? If you can do 1, you can do 5, right? I just thought of a good problem. What class are you? Class of 2021.
Oh my
God.
God.
Like the 2021 partial. Don't worry, I'll find something good.
Is that possible?
Yes.
Like,
When you have sines and trig functions, the things just keep going on and on, right?
Oh, no.
Or even e, right?
oh, no.
Yeah, you can go on and on. Okay, we are done. We'll play a game and then we'll
Oh, no, we don't
We-
have.
we can't go to lunch early today, yeah.
Does it actually matter what order you go in?
Yes.
Like in terms of solving it or like getting the final answer?
Well, both of them are the same thing, right?
No, but because,
You're thinking they should come out the same?
yeah, because if you switch the order, they come out the same. So then you could do del x, del y.
Oh, yeah, that's a good question, learner. You guys see what he's saying?
It's like multiplication.
But then if you do it twice with respect to y, though, that's different then, right? Like if you had with respect to x and with respect to y, that one the order can change, right? But when you gotta do it twice with respect to y, then that might change it, right?
But you could do y first, 2 times, do it twice for y and then x, or do it once for x and then twice for y.
And it should come out the same?
I think so.
That doesn't seem logical to me, but why don't we try it?
Oh, yes.
No, think of an easy function then. How about like
Plus y.
x squared y cubed then? Okay, so you're saying it doesn't matter what order you do it in.
Yeah. I think you could do del y, del x, del y, and it would still work.
Okay, why don't we go y, y, x then?
Yeah.
Okay, what is del y? Okay, I'll do it then. Okay, and then we do it again with respect to y. So wouldn't that be,
So we could do x squared y.
what? Why are you guys trying to confuse me here? Correct?
Yeah.
Now do it with respect to x. Okay, but learner said you can just go y, x, y.
Yeah.
So y is this, then x. Oh yeah,
What about x, y,
huh?
No, we're good.
But it goes through the second y squared.
Yeah, but what if, oh, I don't know.
Yeah, it works.
It works every time, you think?
I think so.
Hey,
It's
remember
like
class, it
Well, what if
works
it was
for
like
one,
order
it works for
equation?
all.
No. Who said that?
I'll do them every way on the.
No, but you can't, but that still doesn't prove it. Then we're probably gonna do a proof by mathematical induction then. What's that? Don't worry, we're gonna learn that after we finish multivariable calculus. Some, put it over your nose. Do you want me to put that in the letter?
Yeah, drops.
I don't know, I've never heard that, maybe it is. Did somebody Google this? Okay, maybe, all these years, nobody said anything. Well, I'll look it up too. Intuitively, so how did you think it might work out like that?
Well, like the note said that if you do like del y, del x, and that's equal to doing del x, del y,
Mm-hmm.
and then if you had to do del y twice and del x,
Oh,
you
so,
can switch those.
so basic commutative property
Yeah,
repeatedly.
yeah.
Okay, now it makes sense. So then what's the point of doing that then? What's the point of giving it an order then? You know what I mean? Huh. Whatever. As long as you can do it, that's the main thing. All right, we'll play one game. So what game did we play last time?
You're gonna play the one that you said you were gonna play about like vegetables or something.
I thought we did that already.
No, you didn't.
No, that's good.
We didn't do fruits and vegetables.
No, no.
Okay, we'll do fruits. You sure? I'm pretty sure we did it.
Do the landmarks one.
Okay, no, let's play the landmarks one more time.
Okay.
Because we still got a lot. Okay, but this time, okay, we're gonna take turns and you can confer in your group then.
No.
What do you mean no?
Hey! Hey!
What do you mean no?